From the alarm app on your phone to the system that gets your coffee order right, our entire world pretty much runs on software. But have you ever stopped to think about how it's actually built? It's not just a bunch of people typing code. It's a really deep, complex discipline. So today, we're going to pull back the curtain and take a look at the hidden world of software engineering.
Here's the plan. We're going to start with a really common business problem and see how that led to an engineering solution. Then, we'll get into what makes software good, check out the principles and tools engineers use, and finally, see how it all shows up in the world around you.
All right, let's kick things off with a scenario that probably gives managers nightmares. It's all about what happens when your most important asset isn't something you own, but something someone knows.
No, really. Just imagine that for a second. You have that one person on the team, the one who knows how all the pieces really fit together. And then one day, they're just gone. What happens? Well, the project grinds to a halt, you start missing deadlines, and a whole lot of panic kicks in.
And this is the real danger. It's not just about losing a good employee. It's that all that knowledge, the history of the project, the reasons certain decisions were made, it just walks right out the door with them. Poof, gone. And the company is left trying to figure out its own stuff. It's a super risky way to run a business.
So how do you fix a problem like that? Well, you start with something called software documentation. It's a pretty simple idea, but it's incredibly powerful. It just means you create a detailed record of everything as you go so that the knowledge belongs to the company, not just to one person's brain.
You can almost think of documentation as an insurance policy for your project. It directly tackles that indispensability problem, making sure the knowledge stays put. But it also makes the software way easier to update or fix later on. And get this, it even lets a company pause a project and pick it back up months or even years later without having to start from square one.
Now, this problem of losing knowledge, it's really just one symptom of a much, much bigger challenge. See, as software got more important, the old, informal ways of building it just weren't cutting it anymore. It was time for a more serious, professional approach. And think about why. Software today is wildly complex. It's not just for simple games anymore. We're talking about stuff that controls medical devices, manages huge financial markets, and coordinates massive teams of people. The stakes are just incredibly high. You can't just wing it when people's health and money are on the line, right? You need a system. So to really get this solution, we need to define our terms. First off, what even is software? It's actually more than just the code. It's the programs themselves, sure, but it's also the procedures for how to use them and, super importantly, all those documents we were just talking about. It's the whole package.
Okay, and what about the engineering part? Well, we don't build bridges or skyscrapers by just guessing, do we? Of course not. Engineering is a discipline. It's about applying proven scientific principles in a systematic way to build things that work reliably and don't break the bank.
So let's put those two ideas together. Software engineering is what you get when you apply that same systematic, disciplined approach to building software. It's about using principles from computer science and math to create cost-effective solutions. And this is the key takeaway. It's about turning software development from a messy craft into a predictable, professional engineering discipline. All right, so we know what software engineering is, but what is it trying to do? I mean, what's the end goal? Turns out every project, big or small, is aiming for the same few things.
You can think of these as the three pillars of any good piece of software. First and foremost, it has to actually work. Correctness is table stakes. Second, real people have to be able to use it without pulling their hair out. If it's not usable, it's a failure. And finally, it has to make financial sense. The value it provides has to be worth more than what it costs to build and run. A huge part of software engineering is just balancing these three goals.
So how do engineers actually hit those goals? They don't just hope for the best. They follow a set of guiding principles and use a whole bunch of powerful tools. Let's look at the blueprint and the toolbox they use.
These principles are like the architectural plans for a building. You start by defining exactly what you need to build. Then, you break that huge problem down into smaller, bite-sized pieces or modules. You use something called abstraction, which is a fancy way of saying you focus on what a piece does, not the messy details of how it does it. And you keep everything uniform, a consistent style, so anyone on the team can understand and work on any part of it.
Now, to actually put these principles to work, engineers use more than just a keyboard. They have an entire category of software designed to specifically help them build other software. And this whole concept has a name: CASE. CASE stands for Computer-Aided Software Engineering, and it's basically the engineer's digital toolkit. We're talking about special programs that help create design diagrams, some that can even write code for you, tools that run thousands of automated tests to find bugs, and yep, even tools that help generate all that critical documentation we started with. It's all about automating the grunt work so engineers can focus on solving the really hard problems.
Okay, we've covered the problems, the definitions, the goals, the whole process. Now let's bring it all back home and see what this all looks like in the real world, in your world.
And here's the beautiful part. All of that complexity, that strict discipline, that careful planning, it all happens behind the scenes. And the whole point is to make it invisible to you so that the apps you use feel simple, intuitive, and just reliable. Good engineering makes hard things feel easy.
The results of all this work are the applications you use constantly. The word processor you use for your resume, the spreadsheet for your budget, the graphics app for making memes, personal assistants, educational software, and of course, all our entertainment. Every single one is a product of this engineering discipline.
So, as we spend more and more of our lives in a world that's built not out of steel and concrete, but out of lines of code, it really makes you think, doesn't it? How important is the blueprint? Well, if software engineering has taught us anything, it's that the blueprint is everything.